Good afternoon, doctors and colleagues. I would like to welcome you to our design thesis project. Let me introduce my group members. Amr Amin, Muhammad Basbar, Taha, Yasser Ali, and myself, Muhammad Khalid. Here is our outline for today's presentation.
Can you tell us what's the title of your thesis?
Design high-rise, design building.
Because you did not put it here. Can you just, at least for the people to be aware, what's the title of the thesis? Okay, design of high-rise building. Okay, thank you.
Here is our outline for today's presentation. First, we're going to give you a brief introduction about our project and its nature. Then we're going to talk about scope of work, design criteria, approach, challenges that might face us in the project, expected outcomes, and our schedule for this semester. First, our project is called Falcon Towers. Located immediately on Coronation Adi, beside the Salam International Hospital, on an area of 10,000 meters square. The owner is the Saudi Egyptian construction company, and there will be 3 consultants: CDEC, Space Consultants, and Crown Home Consultants. It will be used for residential and hotel. The right building will be the residential. It will consist of 18 replicated floors, and it will have 108 residential units. The areas of the residential units will differ from 300 to 400 meters square, and it will have elevators and parking in the building. The left building is the hotel. It will have 130 hotel suites, and it also have some facilities such as reception halls and meeting rooms and other stuff. This is the exact location for our site. The numbers refer to the buildings around our site. 1 and 2 are the 2 most important buildings because they are the neighbors for our site, and they are also high-rise buildings. Now, my colleague Yasser will continue.
This is a layout for the project. Here is tower 1, here is tower 2. We have 3 underground levels. We have basement 1 and basement 2, and both are parking. And we have the back of the house. Then we have 4 different floors, and then all the rest they are repeating typical floors. This is a plan for the ground floor. Here is the outline of the first building and the layout of the second building. The street and the Nile are on this side. The entrance is here, and we have 3 ramps leading to the basement, 1, 2, and 3. We have the neighbors. Here is the neighbors, here and here and here. We have a steel truss in the middle between the 2 buildings at a height of 4 floors, and we have a steel shed at a height of 3 floors. And on the back here there is a swimming pool. The ground level, it's on 3 levels. The ground level here, the 0.6 meters, and then 1.2 meters. We'll design it as 3 slabs connected by beams. The dimensions of the site, it's 120 meters by 80 meters. And I'll leave for my colleague.
Giving you a brief description about scope of work. First, we have to deal with the dewatering, since our project is directly adjacent to the Nile. We'll decide on an effective and suitable dewatering system for a structure. Moving on to the excavation supports, which are basically temporary works for excavation. We'll do arrangement and the design of diaphragm walls, and the arrangement and the design of piles, and also the arrangement and design of wader beams. Moving on to the design of foundation, we'll have to calculate vertical loads due to gravity and lateral loads due to wind and seismic forces. We'll also consider the lateral pressure of soil and lateral pressure and uplift of groundwater. And then moving on to the design of columns and walls, where the seismic forces and wind forces are really significant. We're going to explore the modes of vibration, and we're going to perform dynamic analysis for our structure. Also, we have a structural steel design. As my friend said, we have 3 steel structures. We have the steel shed on the entrance, and we have a space truss in the atrium, and we have a steel bridge connecting the 2 towers at the 4th floor. Also, we're going to be providing design drawings for our structural elements, and we're going to be checking on the numerical analysis by manual calculation. As for the design criteria and approach, our design code is the Egyptian Code of Practice. We're going to be using software programs like SAP 2000 and ETABS and Plexus 2D. Our chosen material properties, FCU for horizontal elements is 30 megapascals, for vertical elements 40 megapascals. Yielding strengths for steel bars is 400 megapascals, stirrups 240 megapascals, and structure steel 360 megapascals. And now the challenge discussion.
Just like any other projects, we'll have to experience a few challenges on the way. First being lateral loads, such as wind, earthquake, and seismic loads. Second is dynamic analysis, because we have to do it to account for the vertical loads. Another challenge is using new softwares that we're not very familiar with, like Laxis and ETABS. We will also be under the time pressure, because this is a high-rise building, and we have to be working on a high capacity building. Last but not least is the nature of site. We have to go 3 floors under the ground level. This is approximately 10 meters right in front of the Nile River. So we will have to work with the dewatering problem. And we assume that our neighbors from both sides have deep foundation and basement levels. And we have prepared a video animation to show you the method of construction for the dewatering. First, we will start with the diaphragm walls, as you can see here, and then construct the piles and start the dewatering process. Then the excavation and constructing the water beams, 1 floor at a time. This is the BOH, basement 1 and basement 2. Then we construct the foundation, shear walls, columns, and the retaining wall, and remove the wader beam when we don't need them anymore. After the wader beam has been removed, we will have to cut the piles because they're not needed anymore. And the dewatering process does not stop unless we reach a superstructure of about 10 floors to be able to overcome the uplift of the ground. That's the piles being cut down.
As for the expected outcomes of the project, we will first analyze and design the excavation site support system. We have already mentioned that the system we're going to use is a diaphragm wall in the video. Also, there will be analysis and design of the RC high-rise building subjected to wind and seismic loads. We will learn to use softwares as previously mentioned, like Laxis 2D for foundations and ETABS for lateral loads. And we will learn how to produce neat design drawings for foundation, to show the construction stages of foundations, of columns and walls, of slabs, of beams, of structural steel bridge and shed. As previously mentioned, we're having a major time constraint, so we have divided our priorities into 2 sets of priorities, the primary and the secondary. The primary are the deliverables that we promised to deliver. These include design drawings for RC slabs for 4 floors. Sorry. It's going to include the B2 level, the B1, a ground floor, and one of the typical floors. Then the design drawings for columns and walls, and the design drawings for foundations. The secondary deliverables will include design drawings and construction method for excavation and site support, and design drawings for steel truss and shed. This is our tentative schedule. We have 3 phases in it. Starting from here to here, this is the concrete design, this is the substructure design, and this is the steel structure design. What's time consuming? What concrete design is more time consuming. It will take us 2 months to finish, but the rest isn't really that time consuming. That's it. These are the list of references that we used, and thank you.
I will start and then I will open the floor for everyone. I am not sure exactly what's the scope of work that you're going to do. Are you going to do the 2 buildings and the bridging between them,
Yes.
or one of them?
Two.
And the second thing, second thing, I have to be honest with you. I don't like to say the deliverable or the outcomes, priority 1 or secondary priority 1 and 2, or main and secondary. I want this project to be well defined. This is what we will do, and this is at the end of the 28 weeks. This is what I want, or the 14 weeks, the 28 lectures, it's 14 weeks. This is what we will finish. So I want you from now to be very decisive. I am going to design building number 1. I'm going to design building number 2, or I have the time to finish the 2. Honestly, with my humble experience, for the 5 of you, you can't finish the 2 buildings in 14 weeks. So you have to be now concentrating, I am going to do this right-hand side building, and this is what I'm going to concentrate on. And I'm going to do that complete, with priority 1 and priority 2 for that building. This is better for me rather than I do this and that, and I do priority 1 only, not priority 2. So please, with your advisor, concentrate on the scope of work. One of the 2 buildings is quite enough. Do it right as far as analysis, earthquake analysis, and design, excavation. Imagine that you don't have anything else around it, and do the method of excavation that you said for that building. So this is better for me than you divide your effort. If you are designing concrete slab here, you'll be designing concrete slab there. Now why are you doing? You are repeating the work. Yes, it is different nature building, but you are repeating the work. I rather see that you have learned something more in the project than repeating that in the project. And in terms of the bridging between the 2, this might be yes or no, depending on the time. That's if time allows that you do it, and this is between you and your advisor. This is my comment, and hopefully with your advisor you take that into consideration. Now I open the floor for questions or comments. Dr. Ayes?
I just have one question. Where did you, in your presentation, you mentioned something about dewatering, and you mentioned that you stop dewatering after you reach the dance floor. Where did you get that from?
No, that's only empirical.
American?
Yes, that's.
We were advised that it's going to take approximately 10 floors to cover. So approximately 10 floors to be able to overcome the force of the uplift of the groundwater.
The uplift. So you have to calculate the uplift,
Yes.
then you have to calculate the load. So it's not 10 floors. Might be more, it might be less, right?
My point was that we're not going to stop the dewatering process unless we reach a force adequate enough to overcome the uplift.
Which is approximately 10.
So the 10 floors is just an approximate.
My second question is, obviously you have water, groundwater table, which is really high, right? So what precaution you are going to do in the foundation? You didn't mention that as well in your presentation.
We thought about doing it using the piles, right? So for the insulation, we were thinking about first we insulate right under the raft, and then we will break the part in the raft where it has the pile. We will break underground, and then we will insulate that area that we broke, and then we will pour this part again, and then we will insulate again on top of the raft. So it has a bit of problems because we were thinking of the way of using the piles and then breaking them. So we're still thinking about a way for the insulation.
I have a question regarding the diaphragm wall. Your animation, you showed the diaphragm wall extending below the mat foundation with pile cap foundation level way below that. Okay, so why do you think this is?
The buckling effect for it, we have to design it. So, probably that. I don't know.
Why didn't we terminate the diaphragm wall right at the mat level instead of extending way below? Is it something?
It won't be a cantilever.
Conceptual question. You don't need to design to know that.
It won't be a cantilever, so I'm not sure if it will have to extend under the point. So we still have to calculate it. Because the slabs will be going into the calculation of the retaining wall. So I'm not sure if it will go.
Okay, so then next presentation probably will have the answer to that.
We consider it.
I guess it is very challenging, the substructure and the dewatering. And then one high-rise building, I guess the steel work, you might consider whether you will have time to do it. Because once you deal with the steel, then this is relatively different nature of that part. So, but challenging, the substructure is very challenging. One high-rise building, one of them is also very challenging. You handle the core and the lateral loads and earthquakes and so on. So I think you better focus on, let us say, reduced scope of work that you can really finish this part.
Actually, first, I would like to clarify something that these two buildings are connected from underneath. So they have one common basement throughout the area of the site. This means that when we are going to design the raft, we will have to take loads from both buildings. So I presume maybe I'm ambitious a little bit in this matter, but I want you to at least obtain the loads from both buildings.
Yeah, simulate the load from one.
And then you can concentrate on the design on one of them only. So, like Dr. Aizat said, that this might reduce a little bit the amount of work you have to do. The other thing, yes, we can eliminate the space truss and bridge, but still we have steel work to do if we're going to go through the excavation site support. We have steel wheelers, so this will expose us to the steel design, so you will cover this topic very good. I would also like to comment on the Dr. Wael's note that diaphragm wall will definitely have to be extended below the raft in order to maintain its stability and also to help the dewatering process. So it's very important that the diaphragm wall should be extended below the raft. Definitely this will be, you'll be exposed to that in your analysis.
I just want to comment, do you understand how many drawings I will be expecting from you? I understand from the fourth floor up, it's a typical floor, so this might reduce it to maybe 1 or 2 drawings. But from the ground floor to the fourth floor, these are 7 floors. Each one of them will require maybe 2 or 3 drawings because of the size, with all the detailing and all that. For one building by itself, I guess the time you're going to spend in producing drawing, not designing, is more than the 14 weeks. So please consider seriously reducing the scope of work. This is better than at the end you come and say, I couldn't finish except 1/3 of what I was supposed to or what I promised to do. Okay?
We were going to do 4 floors, just four floors.
Why 4 floors?
Expected this is.
No, that's to me, I will say definitely not accepted. I rather see building complete rather than 4 floors in 2 buildings.
One complete.
No, I have to see the building complete because you already analyzed it. So I would like to see the design of the typical store. I like to see that.
The
Okay?
time taken to complete the lateral loading analysis, you're going to consider the entire building.
Yes.
But they only use that lower part of the design, I guess. You better finish a complete building.
Okay, so adjust your. Thank you.